In this video, we're going to discuss about the different performance regarding measurement with an oscilloscope and the measurement of an AC signal with a DMM. So DMM is the same DMM that you used in your week 1 lab. So refresh your memory on how to use this. So the way we're going to do this comparison is that we are feeding in simultaneously a sinusoidal or triangular or square wave from a function generator, and we use a BNC T connector here to split the signal into two same signal and have them fed into the oscilloscope channel 1 as well as the DMM respectively. So we're gonna do this for three kind of waveforms: sine wave, triangular wave, and square wave at three different frequencies: 100 Hertz, 2K Hertz, and 25K Hertz. So let's start our measurement. So right now you can see that we have a case of a sine wave at 100 Hertz whose amplitude is 5 volt peak to peak, and we see that the DMM is giving us 1.77 volts. That's VRMS value. So this should be close to what you expect, right? If you didn't get that number from your pre-lab, go ahead and check your calculation, right? So how are we going to do this in an oscilloscope here? Let me zoom in for you. For this particular oscilloscope, you click on the measurement here, mesh button, and then you can add different type of measurements here. You can see all kinds of measurement that we can do with this more advanced oscilloscope. And you click on ACRMS end cycles. You got the number popping up from the bottom of the stack here. Oops. So this number, this shows that this oscilloscope reads 1.77 volts also, right? This is the case for 100 Hertz sinusoidal waves. Okay, let's check the triangular waves now. Okay, for DMM reading we have 1.44 volts as the RMS voltage. For oscilloscope we have 1.44 also. But this still should be close to your theoretical calculation you did in your pre-lab. So okay, this is for 100 Hertz triangular waves. Let's try square waves. DMM says 2.48. Oscilloscope says 2.5. Right? So as you can see that at this relatively low frequency, which is 100 Hertz, the performance of DMM is not too different with the performance of oscilloscopes. So still, you can kind of trust both of them if you're doing low frequency measurement. Now let's ramp up our frequency a bit. Let's go to 2K Hertz. Starting from a sine wave. Okay, so the DMM gives 1.75, a little bit lower than what should be there. Oscilloscope gives 1.77 or 1.78, right? Triangular wave at 2K Hertz 1.42 for DMM, and 1.45 for oscilloscopes. Let's try let's try square waves. Okay, DMM is giving us a 2.2 instead of a 2.5-ish number. And the oscilloscope is still giving us a correct figure, which is 2.5 volts. So, as we can see at 2 kHz or low kilohertz, DMM is starting to become worse in its measurement accuracy. What if we ramp up the frequency even more? Let's see what's gonna happen. Let's say we are testing with a sine wave at 25 kHz. Okay, what do you see? There's an exact 0 popping up on the DMM screen. But let's look at the oscilloscope screen here. 1.77 still. Triangular waves, still a 0 on DMM. .44, 1.45 on oscilloscope. Square. 0 exactly on DMM. And we have around 2.5 on the oscilloscope. So why is that case that DMM do so badly on high frequency measurements? The reason is that DMM doesn't have enough bandwidth to deal with such high of a frequency. So what do I mean by bandwidth? Simply put, bandwidth is the range of frequency that your input signal have that's being fed to your measurement unit, that your measurement units can still accurately measure its properties, right? So let's look at the labels on our oscilloscope here. So our oscilloscope says that it can handle up to, it can handle up to 17 megahertz here. All right, so 25K is still a piece of cake for it. But for our oscilloscopes, if you go ahead and read the data sheet of this for DMMs, if you go ahead and read the data sheet for this DMM, you can see that its recommended frequency range is, for that AC measurement mode, is 40 Hertz to 400 Hertz. So yes, exactly. So DMM cannot handle high frequency, and it's really a design consideration for it. So DMM is really, its AC measurement mode is really meant to measure the power outlet. So power outlet have a frequency of 60 Hertz in America, and it's typically around 100 Hertz or so for worldwide other countries. So it's relatively low frequency measurement. DMM is designed for that. So the take home really for this exercise is, if you're working with AC signals that are above 1 kHz at least, then oscilloscope is really your friend. Don't trust any readings from the DMMs.